Alasdair is performing a science experiment to measure the amount of gas given off by a chemical reaction. He knows that the balloon will fill up at a rate of 3 centimeters cubed per second, and wants to know at what rate the radius is changing when the radius is 5 centimeters. He also wants to know what the change in surface area of the balloon is when the radius is 5 centimeters.
Kyle, how will the math work for our experiment?
In our experiment, we're using a spherical balloon, and we know that the change in volume is 3 centimeters cubed per second. So our formula for volume of a sphere is 4 over 3 pi r cubed. Since r is not a constant, we have to first take the derivative, which gives us dv over dt equals 4 pi r squared dr over dt. We know that dv dt equals 3. We plug that in here, and then that equals 4 pi times 5, and 5 is our radius at this point, squared times dr dt. Then we solve for dr dt, and we get 3 over 100 pi, or 0.010 centimeters per second. Trying to find the change in the surface area at a radius of 5, we use the surface area formula of a sphere, which is the area equals 4 pi r squared. We take the derivative of this, which gives us dA over dt equals 8 pi r dr dt. And since we're solving for dA dt, we already have it alone, and that equals 8 pi times 5, which is the radius at the point which we're trying to find, and 3 over 100 pi for dr dt, which we found over there. And when you work this out, dA dt equals 6 over 5, or 1.2 centimeters squared per second.